Hello everyone, I am Miss Pallavi Shezwa and today in this video we will see the concept partial derivatives. See the contents. First we say functions with two variables, first partial derivatives, notation, rule to find partial derivative of z is equal to f of xy, examples on first partial derivatives, partial derivatives for functions of three or more variables, second order partial derivatives, examples on second order partial derivatives. First we see functions of two variables. A function of two variables, a real valued function of two variable f consists of first a set A of order pairs of real numbers xy called the domain of the function, and second a rule that associates with each order pair in the domain of f one and only one real number denoted by z is equal to f of xy. Okay, here z is an independent variable and xy are the dependent variables. So partial derivatives, if f is a function of two variables, its partial derivatives are the functions fx and fy defined by partial derivative with respect to x, that means fx xy is equal to limit h tends to 0 f of x plus h y minus f of xy upon h, and partial derivative of y f with respect to y is equal to limit h tends to 0 f of x y plus h minus f of xy upon h. See the notation. If z is equal to f of xy, we write fx xy is equal to fx or dA by f by dA by x or dA by z by dA by x or dx f. So what are the notation? If suppose there is a function z is equal to f of x and we have to take its partial derivative with respect to x, that is it is denoted by fx or dA by f by dA by x or dx of f or d1 of f or dA by z by dA by x. If we have to take the partial derivative with respect to y, we write it as fy xy is equal to fy or dA by f by dA by y or dA by z by dA by y or dy f. Okay, these are the notations for the partial derivative. Rule to find the partial derivative of z is equal to f of xy. This is a very important concept. To find fx regard y as a constant and differentiate fxy with respect to x. If suppose we want to find out the derivative of f with respect to x, then treat y as a constant and differentiate fxy with respect to x only. For finding the partial derivative with respect to y, we denote it as fy and we are treating x as a constant and differentiate f with respect to y. See the example. If f is equal to xy is equal to x cube plus x square y cube minus 2y square, find fx to 1 and fy to 1. Solution. Holding y constant and differentiating with respect to x, we get, we want to take the derivative of f with respect to x, that means we are treating y as a constant. See the example. We are going to treat y as a constant. We know the derivative of constant function is 0. Here we are taking y as a constant, therefore the derivative of 2y square is equal to 0. That means fx xy is equal to 3x square plus 2xy cube, and fx to 1, that is substitute x is equal to 2, y is equal to 1, we get the answer 16. Similarly, for finding the fy xy, we are going to treat x as a constant and taking the derivative with respect to y, that is 3x square y square minus 4y. Fy to 1 is equal to 8. See the similar example. Fxy is equal to 4 minus x square minus 2y square, fx11 and fy11. Fxxy is equal to minus 2x, fx11, substitute x is equal to 1, y is equal to 1, we get the answer minus 2. Fyxy is equal to minus 4y, substitute x is equal to 1, y is equal to 1, we get the answer minus 1. If fxy is equal to sin of x upon 1 plus y, calculate d by f by d by x and d by f by d by 1. We know the derivative of sin x is cos x. Here it is a composite function. That means we again have to take the derivative x upon 1 plus y. So we get answer cos of x upon 1 plus y into dabba by x upon 1 plus y is equal to cos of x upon 1 plus y into 1 upon 1 plus y. Similarly, dabba f by dabba y is equal to minus cos upon minus cos x upon 1 plus y into x upon 1 plus y square. Partial derivatives for functions of 3 or more variables. If suppose there are 3 or more variables, if suppose there are 3 variables, we say that x, y and z. We have to take the partial derivative with respect to x. We write it as fx x y z is equal to limit h tends to 0 f of x plus h y z minus f of x y z upon h. It is found by regarding y and z as a constant, differentiating f with respect to x. For example, find fx, fy and fz if fxyz is equal to e raised to xy ln of z. For finding the derivative with respect to x, that is fx, we are treating y and z as a constant and take the derivative of f with respect to x. Okay, we know derivative of e raised to x is e raised to x, that means e raised to xy. Again we have to take the derivative of xy with respect to x, that means it is y ln of z as constant. Similarly, fy is equal to x e raised to xy ln z and fz is equal to e raised to xy. What is the derivative of log? Derivative of log is 1 upon z. So it is e raised to xy upon z. Second order partial derivative. What is the second order partial derivatives? If f is a function of two variables, then its partial derivative fx and fy are also functions of two variables. Okay, so we can consider their partial derivative fxx, fxy, fyx, fyy. Taking the derivative of fx with respect to x, we get fxx or dabba 2f by dabba x square, dabba 2z by dabba x square. Again, if suppose we take the derivative of fx and again taking its derivative with respect to y, we get fxy, which is equal to dabba 2f by dabba y dabba x or dabba 2z by dabba y dabba z. Similarly, fyz, that is taking the derivative of fy, partial derivative of fy with respect to x, we get dabba 2f by dabba x dabba y or dabba 2z by dabba x dabba y. Fyy, that means taking the derivative of fy with respect to y, we get dabba 2f by dabba y square or dabba 2z by dabba y square. Thus, the notation fxy or dabba 2f by dabba y dabba x means that we first differentiate with respect to x and then with respect to y. In computing fyx, the order is reversed. Take the note dabba 2f by dabba y dabba x is equal to dabba 2f by dabba x into dabba y. See the example. Find the second partial derivatives of xy is equal to x cube plus x square y cube minus 2y square. In example number 1, we found that fx is equal to 3x square plus 2xy cube, fy is equal to 3x square y square minus 4y. Take the derivative of fx with respect to x. that is treating y as a constant and taking the derivative of x. We get the solution 6x plus 2y cube. Similarly, take the partial derivative of fx with respect to y. We get fxy, that is treating x as a constant, that is the derivative of 3x square is equal to 0. Only we have to take the derivative of y cube, which is equal to 6xy square. Again, for fyx, treating y as a taking the derivative of fy with respect to x, we get 6xy square. Fyy, again taking the derivative of fy with respect to y, we get 6x square y minus 4. Observe that fxy and fyx are equal. So in each and every cases, the derivative dabba to f by dabba x dabba y is always equal to dabba to f by dabba y dabba x. So in this session, we see the concept of partial derivatives, its notation, example based on this. Thank you.